Hello, this is BKEP here at the Institute for Protein Design, here with my colleague Ian H. We are here with lab report number 5. We have big news this month. We are introducing a new member of the Foldit team. We have Henry coming to us from Illinois.
Hi everyone, I'm Henry. My background is not in protein science. It's really all over the place. For software development, I have worked at a startup in Boston. I've worked in a neuroscience lab in Pennsylvania. I also did an internship at NASA, working on some virtual reality modeling of spaceship parts and things. So lots of fun stuff there. In the world outside of software development, I volunteered in the Peace Corps, and I did a degree in music and a degree in mathematics. The first thing I'm probably going to be working on as a new part of the team is some quality of life improvements for the electron density puzzles in Foldit. Looking at the electron density puzzles as they are now, we know there's some less than convenient interface decisions in the way that they're run. As someone who's played a few Foldit puzzles myself, it's definitely quite different from other electron density software like Coot. It's a bird of some kind. Everything's on the screen all at the same time. So we're going to be hopefully working on making that a little more usable. If you have any suggestions for specific things you'd like to be improved, feel free to send me a message on Foldit. My username is milkshake.
We are very excited to have Henry on our team. He's going to solve all of our problems in Foldit. In other news, we have a new blog post about a recent paper on protein structure prediction. This comes to us from AlphaFold, from DeepMind in London, who have come up with a new technique for protein structure prediction. So check out the blog post. We have some discussion about their technique and what it means for Foldit. Puzzle updates. We have 4 puzzle updates this month. First, we saw more poly-proline design from NeilPG628. That is all moving along very nicely. Happy to say NeilPG is working hard on some new tools for Foldit players. Hope to release them very soon. Second puzzle update, we had a CRISPR puzzle. This is a prediction puzzle about a new protein called a transposase that is recently discovered to associate with CRISPR molecules. This is very exciting for the field of CRISPR and gene editing techniques. So stay tuned for more CRISPR-related puzzles. We may even have some electron density maps coming for that soon. Third, we had some more symmetric design puzzles. These are symmetric design with hydrogen bond networks. Again, we are just looking for more designs from Foldit players with satisfied hydrogen bond networks in the core of the complex. Lastly, we had a outlier symmetric design puzzle. This came from an idea that some people in the lab had that we could make a 3-fold symmetric Tim barrel. So this is a Tim barrel with 9 strands on the inside and 9 helices on the outside. We're curious if Foldit players could come up with a backbone that could fold up into a Tim-like structure with 3-fold symmetry. We have a design of the month. This month from Silent Gene, designed a brilliant solution to puzzle 1782. This is a symmetric tetramer design puzzle. So now we have 4 chains, and I want to take it for a spin and fold it. So here on my screen, I'm looking at this design from Silent Gene. Let's see, if we focus here on just the monomer chain, we can take a look and we see that this is pretty nice. We have lots of blue residues on the outside. There is at the designed interface, there is a pretty large patch of orange residue. So this is something we want to be a little bit careful about. This is a place where this protein will be sticky in the cell. If this protein folds like this 4-helix bundle here, this large patch of orange residues will stick to any other hydrophobic stuff in the cell. Hopefully it will stick to other copies of itself as Silent Gene has designed. So if we turn that back on, we can look that there is looks like a very nicely packed interface here with its symmetric partners. So if these do bind, we expect them to bind pretty tightly. It's kind of just a matter of will they stick to other stuff within the cell. But we do also have a very nice hydrogen bond network in the core here that I want to hammer home again. So again, this is a very nice network that looks almost completely satisfied. We have a asparagine here that makes hydrogen bonds with 2 symmetric partners, and then that network extends outward to the surface of the protein via this aspartate and finally a tyrosine. And I think this last tyrosine, can probably make contact with water, and this network would be completely satisfied. I wanted to point out there was one, let's see, I thought there was a tryptophan somewhere. Here we have a tryptophan, this big bulky 2-ring residue that has a nitrogen group on it. This nitrogen group has a polar oxygen that will, or has a polar hydrogen that will want to make hydrogen bonds. And in the solution, it is just shy of making a hydrogen bond to this neighboring residue. So this worries us a little bit. We want to make sure that all of these polar hydrogens can make hydrogen bonds to other residues or with the surrounding solvent. There is a good chance that some solvent could get in here and make a hydrogen bond, especially if some of these other side chains can flex a little bit and move around. But we want to be very careful about these polar hydrogens on blue and red atoms. They will all need to make hydrogen bonds either with other polar atoms in the protein or with solvent, the water that surrounds the protein. So this is an excellent design from Silent Gene. If you've been watching these videos, you'll notice that we've been focusing on hydrogen bond networks in these designs of the month. This is just, we really want to hammer this home for Foldit players. We think this is our best shot at really nailing this problem of symmetric protein design. So we encourage Foldit players to keep working on hydrogen bond networks, look for these completely satisfied networks. These will make your protein more soluble and more likely to behave well. So please continue to share with scientists your favorite solutions. We want to know what you're working on and what you think is exciting. That's all we have this month. Thank you again for watching, and thank you for playing Foldit. We will see you next month.